It is 4:45 on Friday, and I'm still up here for you. Did you get that? I'd love for Austin Allen to watch this video so he could realize how much I actually work for you. I do a lot, but he's not going to watch it. So somebody tell him that. 4:45. I'm still working for you, not me. Because look at these eyes. I'm tired. Write the standard form of the equation of a circle with radius r equals 8 and a center is 5, -2. You don't need my assistance for this. You just have to remember a form. Some of you do. At least 10 of you know this form. Standard form of a circle is x minus h squared plus y minus k squared equal to r squared. That's the hint you need. Plug crap in. In geometry is when you were introduced to h and k notation. Probably Algebra 1 when they did absolute value, but I don't know how Miss Garner teaches it. It says one of the zeros of a certain quadratic polynomial with real coefficients is 10 plus I. What is its other zero? The hint I want to give you is actually something I've done already as I went through and did this twin. I just have to find it. Right here. So I'm looking back at number 6. 1 0 was -2/3 plus I root 26 over 6. And the other was -2/3 minus I root 26 over 6. Complex zeros happen in conjugate pairs. Imaginary zeros are always conjugate pairs. In fact, that's true for all weird zeros. They're always conjugate pairs. All the weird ones. Whole numbers, they can be whatever. One of them can be 2, one of them can be 12. But your weird ones, where you have like 2 plus root 3, the other one's got to be 2 minus root 3. So that's that one. All right, so there's your hint on 17. You should be able to figure it out now if you actually watched it. Population P in thousands of a city from 1990 to 2004 can be modeled by the equation P equals 367.55 E to the negative 0.01052 T, where T is the year with T equals 0 corresponding to 1990. According to the model, during what year the population be approximately 275,000. You're a little too young to even bother YouTubing logarithms because you don't know anything about them, so good luck teaching them to yourselves. But an easy thing to do here would be to realize that if this is 1990, then this is where time is 13. This would be where time is 55 and so forth. Just plug these in. Plug numbers in. You'll get the right answer, I promise you. Pick whichever one's closest, right? It says approximately. 19, expand the logarithm. Oh, well, here I was talking about logarithms. Expand the expression log x squared over the cube root of y as a sum or difference and or constant multiple of logarithms. So there's 3 rules to these. There's actually 4 logarithm rules. A couple of you guys have memorized them all. You have a short version that a log of containing the elements a and b is a logarithm of a plus the logarithm of b. That's not the one I want, by the way. There's this one. There's log of a over b can be broken apart as log of a minus log of b. That's the one I want, okay? So I'm going to take this bad boy right here, and I'm going to break it into 2 distinct logarithms. I would have log of x squared minus log of the cubic root of y. All right, now what else can I do? I'm going to give you two more hints, and then you've got to figure out the rest of this crap for yourself. There's this rule. A logarithm with an element of a to the r is r log a. That's talking about where you can put exponents. One other rule, and it's not a logarithmic rule, it's talking about this cubic root. It says x to the power over the root is the rth root of x to the power. So I'm going to give you one last hint. This y has an understood 1. Using this rule right here, read right to left, the cubic root of y to the first is equivalent to y to the 1/3. And I have given you every hint you need to be able to answer number 19. 21, you don't actually need my hint on that one. You've been doing that on ACT practice on your basics quizzes for a while. 22, you don't need my assistance on that. You don't, because you've been doing that for a while. So no, that's the easy problem. 23, the volume of a small drum in the shape of a right cylinder is 224 pi. The radius of the drum is 8 feet. Find the height of the drum. You don't even need my help for that. Because if you're looking at these bonus questions, you most likely know your formulas. A right circle, you have this on your quizzes. I know you do. You've got volume of a cylinder. It's pi r squared height. Plug crap in. All right. Plug stuff in. You can do it. 38, you do need my help. So I'm going to do something similar. Okay. I'm going to divide, I don't know, let's go 6x squared plus 8x plus 10 by 2x plus 3. This is done with long division. Remember the old long division from being a kid? I'm actually going to get a separate piece of paper out for this because I'm going to need more room because long division take a long time. To make a 2x become a 6x squared, you have to multiply it by 3x. And you remember long division in the old days, you just multiply down. Well, now you invoke the distributive property. There's two things down here. You distribute to both terms. 6x squared plus 9x. I can think of countless hundreds of kids who don't listen to me. You always wrap before you subtract. And like, what did I do wrong, Mr. Milbrath? Because they always get sign mistakes, and you're going to be one of them too, because you won't wrap before you subtract because you think you know better and you don't. 8 minus 9 is negative x. What they do is they get careless and they do 8 plus 9 and write 17. It always happens. Wrap before you subtract. This is kind of funky. This one's a little rougher than it should have been. But anyways, just the way it worked out. How do you turn a 2x into a negative x? You multiply it by a negative half. Like I said, it's kind of funky, but it is what it is. That'll give you a negative x minus 3 halves. Wrap before you subtract. Otherwise, you make a sign mistake. When we add down, we'd have 10 plus 3 halves, which is going to be 23 over 2. And this is a stopping point because you don't have an x. You're not going to multiply 2x by anything with a positive exponent to become 23 halves. So we have a remainder of 23 halves of the original divisor, 2x plus 3. Now the example you've got to do on this thing is easier, so don't sweat it. This is an easier problem by far, way easier. But notice how they always write the, oh, they actually did something simple. They actually did something else. They actually simplified the remainder, but anyways, you'll see that when you get to it. But that's how you do that. Oh, sorry, I can't breathe. This is like a really easy one too. That one's really, really ridiculously easy. Why is that on a math contest question? It's like the easiest thing in the whole page. There is your twin for your test on Friday. You're welcome.